Hey everybody, this is Larry. This is day 11 of the Leetcode Day Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's poem. And of course, we have, part two of, I've been trying to avoid spoilers on even my Discord because I need to, after today, I need to impose like a sort of a spoiler rule for these uh, um, progression sets, I want to say. But yeah, but it seems like this is going to be the same as yesterday. I don't remember what it is already though. So let's go. Let's take a look. Without further ado, but well, okay, maybe a little ado, which is I did do I won like 10K today, so at a progressive pace, it was okay. I feel okay, just tired. So yeah, hopefully I stop being so lazy and get a little bit more in shape. You eat more, really. That reminds me. Okay. That reminds me to eat, but I have to do that later. All right, let's take a look at today's problem. And those of you who wonder why, I know I sometimes in this intro I don't always remember to remind people, but people ask me why sometimes I'm talking about my fitness training thing. And just to be clear, it's not to humble brag. It's not nothing to humble brag about, but it's just that you're watching this because you're struggling with certain things, probably Leetcode, maybe other stuff as well. And I'm just kind of going through the same thing with fitness and trying to get in a little bit better shape, and try to emphasize, right? Emphasize? No, empathize, because it's hard. It's hard to find a motivation. It's hard to kind of keep that motivation steady. It's hard to keep in shape, and it's hard to just like get out of bed, right? So I feel all that. So that's why I talk about it sometimes. Today maybe I didn't talk about that much except for to give a very quick summary or whatever. Anyway, let's take a look at today's problem. We have 3721, longest balance Subarray 2. I already forgot. All right, Subarray is balanced with a number of distinct even numbers. In the Subarrays, you go to a number of distinct odd numbers. Okay. Within the length of the longest balance, I guess that is yesterday's, right? The first one is 10 to the 5th, which we expect because yesterday's n squared, and that was fast. Yeah. Okay, so how would I do it? I think the first kind of idea that we're going to explore is what I call a contribution. And this contribution kind of fits in with sliding window and other type of idea, depending on what you need. But the idea is that, that for O of for n is equal to 10 to the 5th, you need to do things in either O of n, ideally, but also n log n, right? And the only way you can do n log n, really, is that you look at each element once, and for that time, you do something in log n as your kind of upper bound, almost like kind of working backwards. But that's just things that comes into my mind. Like I don't know that I'm explicitly thinking it like that, but the contribution kind of puts that in the thing of that. Okay, well, if we have an array, right, and let's just say 4 is the last number. Well, for last number or the right side of a subarray, how many possible left subarray are there, right? I think that's the biggest thing. Honestly, I don't know how to do this, but that's kind of the idea. Okay, so 4, for example, if our last number is 4, we have all the possible left subarray to consider. Do I want to do? There are two ways to go about it, right? Maybe there's some like search thing that takes log n, and maybe that's fine. And then there's the sliding window of doing it incrementally, right? And then the biggest or the first question, I don't know. I guess the next question is always the biggest because that's the one you're struggling with. But the big question right now is how do you find, given a subarray, the distinct number of even numbers and distinct number of odd numbers? And I guess I want to say it doesn't feel like sliding windows because for each number it can have multiple answers, and those answers are not contiguous, right? Meaning that I don't know. I'm just going. Let's pretend they're all unique anyway. So we just have like odd even or something, right? Well, you might just roll something like very naive like this. Just even if this is your last element in your subarray, then that means that this is a balanced one. this is a balanced one, this is a balanced one, and this is a balanced one. Okay, but not this, and not this, and not this. So it's hard to, in general, get whatchamacallit, it's hard to get a sliding window with that setup. But it does remind me of, okay, but I mean, it reminds me a little bit of this. I don't know if this is the right direction because I don't know the answer yet. I don't know the solution yet, so I'm just going through my process review. But the next idea that I might have is that it reminds me of the if you take away the distinct part, then it is something that we talk about. I don't know if is this just like early in the week or maybe recently anyway, because it just comes up so often in Leetcode, is that you have this dynamic programming where it's a sort of a prefix sum, right? So that you can go, okay, you count this at a time because you have a delta of 0 that goes through like all these things or whatever. I'm not gonna go into in detail because I don't know that that's the right direction to take. I just want to point out that these are the things that I'm thinking about. Also, I'm wrong. This is the longest. Okay. So, yeah. Okay. The longest is a little different. Right? Because for some reason, I was doing the count because I was like, oh, this is what. But maybe longest is different. I mean, it might also not be, but it might be, right? I mean, if we use the same analogy, then it would just have like unique things on the left, and then you kind of do it, right? Okay, so I mean, so that's how you would do it without the distinctiveness, without the uniqueness. And maybe what's next is to just play around with uniqueness, right? So let's say we have, I don't know, A, B, C, A, right? And maybe letters are not so smart. 1, 2, 3, 1. And then maybe, I don't know, just a 4, right? So this is going to be good, but this is also good, right? Because the 1 is not a new thing. So this is good and this is good, though it is not the longest. So how do you know how far to go for each element? Like here, if we add another odd number, then, well, I mean, this only goes up to, maybe it doesn't even go anywhere because maybe this is not possible. And you add another even number, and then this is good again, right? It goes up to like here. And actually, it goes the entire way. So, there is some insight that I feel like I'm missing a little bit. It's nothing too weird, right? I mean, number is up to 10 to the 5th. Maybe we can use that. Can we use that? If it was alphabets, then it would be a lot easier with 26. But I don't know about... Maybe I should have took a nap before doing this. But, okay. Right now, I'm just trying to think whether I need to keep track of everything, or in a way that, like, do I need to keep track of the longest, or even is fine? I mean, the thing that we can do is maybe delta, but how do we do delta with unique? Or how does the uniqueness thing fit? Does the unique thing matter? No, it certainly does. Probably. Because I want to say that it maybe, and I don't know that this is true, and it probably isn't, but I wanted to kind of think, and that's what I was thinking about, is that maybe if we think only about the longest balanced subarray, maybe the uniqueness doesn't matter as much. I think it does, but it's just something that I'm thinking about. Can I do a binary search? Not easily. Is there a DP? Don't think so. Also not easily. What is a prefix sum idea that I can take advantage of? Wow, there's like 5 hints. That's a lot. Maybe even excessive, but I don't know. Well, I don't know. I don't know how to solve it, so who am I to judge? But okay, so given I'm trying to think, if given a subarray, can you even figure out how many distinct odd numbers or even numbers? So maybe we try go backwards. I don't know if it works, but in built in an incremental way, that is, you know. And then the other thing that I'm thinking of is, can we build something that's for even and then odd? Like right now I'm thinking of putting them together in some way, but can I build something that's for even and then odd and then combine them later, right? Okay, let's say we have only distinct even numbers here on the subarray. What would give me a fast answer? Yeah, okay. No, I mean, I was just thinking if it was alphabet, it would be much easier, but because then you could do like a prefix sum on all the alphabet. But obviously we can't do that here because it's again 10 to the 5th. So yeah, how do you do it without checking every number? I guess that's the hard part, right? For uniqueness. This is gonna be a long video, sorry friends. And I'm tired, so I'm not even like because then as soon as you have a 4, then how do you query? So you have a 4 here. You only query even numbers. Okay. What does the unique thing do? I don't know. Wow, today I'm just not good. I'm yawning a lot. Feel free to fast forward, by the way, of course, or skip ahead, whatever you need to do. You're not me right now. Suffering. I keep on thinking ideas around sliding window. I don't think that works. Okay, so let me step back a second, right? So, okay, so let's say we have, this is the last number. How far can we go? Well, I mean, the naive way is just to kind of do going to the left and it'll be n square, right? So, okay, so we know that works. That is definitely, you know, it's going to definitely be correct, but can you do it in log n time? Repeat doubling? No, but the problem is that if you do, like, you can't search for a point. Well, repeat doubling is O of n anyway. Yeah, I mean, the problem with repeat doubling and binary search is that it costs O of n to check, so then it just sums to O of n. It's not an O of 1, which would make it log n, right? Can I make it into an O of 1? Given a subarray, return how many distinct numbers there are, even or odd. I mean, you could have two things, so if you have that, then that's fine. I'm yawning a lot, which is not a great sign. Also, I made the mistake of eating a lot of Indian food earlier. Indian food is fine. It's just that the volume, especially of rice and carbs, I think I'm just hitting a food coma now, is my point. But I mean, I don't know, unless there's some like data structure I don't know about. Can I walk it on a segment tree or something? Like that's the kind of binary search that would happen. What would that look like? I don't even think that's a thing. That doesn't even make sense. And then you, man, I really have no idea. Can I? Can I binary search and then have a sliding window? Would that be fast enough? Maybe. Why didn't I think of that? I think it's like n log log n though. Well, n log square n, whatever. Yeah, I mean, that makes sense though. But it's n log square n. I don't know, is n log square n fast enough? What's log n of 10 to the 5th? Like 12? No, it's not 12. What is it? I mean, it's less than 20, so it's like, what, 16? 17? So 17 squared times 10 to the 5th is probably too big, right? I know it's too big. I'm just like hoping that my math is in my head as well. 29 million. So that you can do a sliding window if you're able to do the set stuff fast enough, or like the uniqueness part fast enough. Sorted list would be definitely be too slow. Segment tree you could do it, but also too slow. Do you have an O1 data structure for this? Yes. What are you doing? Just keeping it in an array. And then just keep track manually, right? Is that right? Maybe? All right, I'm going to try it. Maybe I'm overthinking it a little bit. All right, so no, you can't. What are you doing, Larry? No, that doesn't make sense. You can't binary search because the longest band subarray could have, say, 3 but not 4, or 5, or the other way around. Could be 4 but not 3, so you can't binary search. What was I thinking? No, that doesn't make sense. I mean, it makes sense that you could have a or one wordification for a given thing, given length, given answer, but you can't binary search for it because it's not continuous, or it's not like monotonic or whatever, right? Okay, so no binary search, no sliding window. What else is there? Do I know this one? Is it unknowable? or is it like not sub by me without knowing something? I guess it's the opposite of unknowable, but it's just like red. Like maybe I'm missing some maths that I don't know or something. But it's no like union find e things either, right? Looking at the examples, hoping that would save me, but it hasn't really. 10 to the 5th. I actually don't remember yesterday's. I think that's a big thing, possibly, but I don't know how to take advantage of it. Well, I mean, I had the idea with the binary search, but can I do it in any other way? When you add new elements, now if you add elements, it could definitely turn it into unbalanced. Do we have a set candidates? No, it's definitely not. So when you remove an element, it can go down or not. I mean, my other idea with sliding window may be that, you just do it on the last element being one thing or the other. Maybe that works. I don't think so though, because you don't know when to stop or start. So then what's the idea? The idea is still that you have to find an index that is balanced just in log n. Right, so like you have 4, this goes to no, this is not it, this is it, and then that's it, right? How do you figure out that this is what you want? Can I do some maths? Like, so okay, so you're going backwards from here, right? If you're considering this is your last one, or you go forward, it doesn't matter. But problem is that you don't really reuse the uniqueness, right? Because let's say you have 5, then actually to this 5, this 4 is the first one, and then the 6 is the dupe, right? But from 1, then this 4 is the unique one, and well, you just don't get to 4. But so that means that the dupiness but can I just transfer it? Can I transfer the math? Okay, so let's just say we have, okay, so +1 for odd, -1 for even, plus, well, I mean, it goes to 0. And then +1 for odd, -1 for even, and then plus, was it? +1, right? And then the 4, the thing about the 4 is that you only have to transfer once, right? Meaning that, okay, so then now, because I'm kind of misaligned. I see, I think I'm getting an idea. Because then now 4, you want to say -1 to make it a 0. But the thing is that then now, because this 4, there is a 4 before at this index, and so then we can just make this 0, which means that we have to add a +1 to this subarray, right? So we add 1 +1 to this subarray. So then this is now +1. And then now the 4 can use this -1 here, which is +1, right? And then now you can look to, is it true that you can do, I guess you can fit all of them. And I think that's the way to do it. And because we are trying to, so then there are two things. I mean, I don't know if this is the right way to do it, but this is this feels like something worth exploring, right? Because, so what have I discovered, to kind of summarize it a little bit? What I've discovered is that, you know, and this one is actually pretty basic. I don't know why I didn't write it out earlier, but you know, this is the non-unique way of doing it, right? Except for now we have to take account unique. And then the unique is that we always only take a subarray because, for example, we have another 4. We do not need to do all of this. We just need the last 4. So that's easy to keep track of, right? We just keep track of the last time this number showed up, and then for that subarray, we just increment by 1. And if we want to increment an index range by 1, then that is just segment tree some kind of, or segment tree implementation type thing, right? I know I'm a little hand wavy here because I'm trying to like also keep my train of thought, otherwise I lose it, which happens a lot. But then the question is then, now, let's say we have 4, we increment these 2 by +1. The question is then, well, one thing is that you always only plus or minus 1. What I want to say is that, let's say this is 4, now we have a +1, but to keep it balanced, you have to find the earliest +1, right? But how do you do that in a segment tree? How do you find that the earliest +1 is this? And also what happens when you change it, right? What if, you know, you change, technically there's a no set 0 in the front, but like if this changes to, can it change to +2? I guess it can't, but you get the idea. Because let's say we just subtract this by 1 because maybe there's a 1, right? So then now, how would you figure out, you know, how would you figure out, well, 2 things, right? So you went from, let's just say you have this, right? And you're trying to process the 1. So your initial thing is going to be 2 + 1, 0, right? And then now, after seeing this 1, you go, okay, well, we have to modify this subarray to subtract 1 to counter the effect of the first one. And then this becomes 0, which is fine. But then now, the map changed in 2 places, right? How do I set it up so that this is like, how do I set it up for the future so that whatever would map to the +1 goes to 0, right? And therefore not mapped anymore, and also how to create a -1 without going through every element of the subarray, which if you do, just makes the complexity not tenable. And then the idea that I may have is that I don't know. I mean, I don't think that makes sense, actually. I mean, or it's the same complication. What I was thinking through was that, okay, if we subtract -1 from this subarray, that's also equivalent of adding +1 to everything on the left and to the right. But I think that just like ends up being the same, right? Like, you just have the same issue. But the question is still like, how do you figure out, you know, the new mappings, if you will, right? Like, and it can get crazy, right? So you have like +2, +3, +4, say, right? And then now you have dot, 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 and you want to increment all of these. You want to, let's just say you want to increment all of these for some reason, or decrement it, right? Because it matches this one. So then it goes to 0, +1, +2, +3. The 0 won't get matched, but now if you have a +1, how do you match the +1 with this cell and not this cell? Or index, rather. So we have like a lot of this stuff, but maybe we're still missing one piece, one idea. I'm doing it like so tired, my eyes are passing out. My eyes are like very heavy and sleepy. Not quite passed out yet, but that's definitely not a no-brainer. Or is there any other idea, right? Is there a pigeonhole principle? No, because this can go like, because my idea was that, okay, maybe it doesn't matter, but maybe it does, because you can go all the way up to like +6, +5, +4, +3 at the end to match, but then this would match this, right? And you don't want it to match this. And that would still be the longest one because nothing can match the other things, right? I feel like, yeah, it's given me a sort of an idea. Something to play around with. How do you keep track of the lookup of the earliest? I mean, I was gonna also think about like putting all these numbers in the set, but when you update, you still cannot update fast enough. Like you cannot update every number inside. You have to figure out how to do it all in a group, and that's the and maybe this is not the way to do it, but I think it's still like just, I don't know, but it's still like a closer answer. I feel like. Um, do I maybe do a second segment tree? And then do a binary search. So that gives us a n-log square n again solution. Because the idea here is that we just put all these numbers in a. I don't think this actually works, but in theory, put all these numbers in a segment tree. You decrement a bunch of them, and then just a binary search to see if it contains the number 3 or something inside some suffix of the search space or whatever. Is there something pigeonhole-y that I can take advantage of? Because negative, well, yes, well, I don't think so. I mean, like, you can take advantage in the sense that you know that in this particular one, the +3 exists, but it's not going to give you the longest one if you're not precise about it, right? Or it just gives you the wrong one. It could be a long number, but But this would be so cool. This is such a fun idea, though. But I don't know how to bring it all together at the end. Can I just delete a number? I guess that's what we're doing here, right? Is that on a unique number, I kind of Well, we delete a number. It is basically just updating the subarray. Can I go the other way? Can I? And remove numbers along the way? No, I don't think so. Well, maybe. Okay, so let's say we have the for array. Can we remove numbers? Is that easier? Going from the end to the right to 3, you have the entire thing. Okay. No, because then it's just the opposite problem of, okay, you remove a thing, and then now you have to undo the next ones, and then is it though? Yeah, no, because the next one can be just like really big, right? Wait. No, because I mean, I don't. Even if you reverse it, you still have to make changes because the reverse. Okay, no, that doesn't make sense. Sorry, friends. This is a struggle today. Hope you were fast forward if you're up to this point, or at least watching it on 2x. Maybe it is something similar to this. I'm just thinking about, okay, maybe the reversal of this does make sense in some way. So you have 0 plus 1 plus 2 plus 3. Let's say we dot it, and then now we have the same numbers. It's just plus, I just say is another plus, I don't know, it goes up, down. Then now we have another number that is a dupe of this number. So then what? That means that this doesn't count anymore. And if you go back, that means that you either change all these, or you could change all this. And let's just say we change all this, then now you have negative 1, 0, plus 1, plus 2, and then does that even make sense? I don't even know if that does, to be honest. Maybe it's the other way, actually. No, that doesn't make sense either. I don't know. I mean, no, I don't think this makes sense. Okay, because I was thinking about working backwards, and what if instead of building this thing, well, I guess this doesn't make sense because I built this out of nowhere, right? So okay, so let's just say we have, I don't know, let's just do this one real quick, right? What we do it in reverse. So now we have an empty 0, empty set 0, we have 3. So this 3, let's just set this to a new 0, and then that means that all the prefix will be -1, right? Or subtract 1 from all the prefix, right? And then now you have a 2, which is technically a +1. But now we wanted to 0. So then now we just +1 on all the other ones. And then now we're just looking for the first 0, right? And can that be binary searchable? I mean, the other one is 2, but can we do a segment tree walk? I guess that... Actually, I mean, even the other way, we could have done a segment tree walk. What am I thinking? Because you just choose the min and the max, and because all the numbers are contiguous within a range. Yeah, okay. No, I'm just being dumb. I think segment tree answer makes sense anyway, even without this thing that I did. So this way certainly works as well, I think. I don't know if it's clean or not, to be honest. But yeah, let's do it this way. I mean, I think I got it. I think I was just confused. Half confused, but so many things to consider. I just forgot about the segment tree walk. Um, okay, at 40 minutes in, we're able to finally put code in the thing, but I think I want to say I'm happy about it. In terms of, I'm happy with the approach that I have. I think that's true. And I have to do my Duolingo. But I'm trying to think. First of all, I am going to find my segment tree range range update. Okay, let me try to think real quick. What a segment tree I want? So I want a segment tree that range updates and also allows me to walk to find the first zero, right? So it has to be whatchamacallit, lazy propagation, and then for each segment tree node, we have to keep track of the range. Yeah. So then we want a segment tree that's max min. Okay. So let's. I always forget the exact syntax for it, so I might have to reference it somewhere. Well, not syntax, but the whatchamacallit, the interface. So we have n for a number of things, right? So we want to say min value is equal to times 4 times n, is it? I always forget about it. Uno goes up to my door. I think it's the delivery person. Oh yeah, and then the push thing, right? I guess it was fine. Okay, so I'm not gonna go over too much about segment tree. I'm still trying to get to a point where I can implement it from scratch. But honestly, I haven't been doing that lately, so I'm a little bit rusty. So I'm referencing an old code that doesn't have all the things that I want, because otherwise maybe then we're just done. But yeah, okay. So then now, what do we want to do first? We want to do add, right? So you have, which one do I want? Oh, I want the first 0 version. So we would update the prefix instead. Maybe that's a little bit easier to, instead of searching. Okay, so then now we want the left, right, increment, right. Value. Then now we can just oops. How'd I go? 0 and -1. Left, right, incrementer is fine, right? And then here we go. I always forget what to name them, because it's very confusing, I think, sometimes. Am I missing one thing? I am missing one thing. That's the range. We're about to get the current node. Okay, so that's the node range. Yeah, and then these are the input parameters. I mean, you could do them in different order, so sometimes I just, forget. Node left, node right, left, right, incrementer, right. And then now there's a push component as well, but something like this. No. Then we just return. Otherwise, we have to. Okay, so if I always forget which direction. That's why. Okay, so this is a subset, right? Because this node is within the query range. So then now we set min value of node is equal to min. Let's. People ask me why I write this out sometimes. It's just because it's faster, or like it's faster to run, and I'm very much worried about the performance for this problem. So I guess now we have like now we have whatchamacallit, not the sum of execution time, the opposite of it. So I don't know, we'll see. But I'm still like used to it, so we'll, Okay, so node of and then wait, no, that's just setting the value, right? We have to, because we're shifting everything up by incrementer. Yeah, so the initial values are actually wrong, but that's fine. We set them to 0 instead, because then now you have a range of 0, 0. Maybe fine, right? And then we also have to push, right? Something like that. And then we need a push thing so that it marks this thing as done, and then do it on the children, right? So then now, yeah. Is it no one? How do I write it? +1, right? Yeah, we have 0 index first, so this is the way to do it. Yeah. Yeah, a lot of copy and paste. Oh well, forgive me. Okay, so that's the general push code, because basically the idea from first principle is that, okay, if this is within a segment, then we want to update this. If this node segment is within the range, the query update range, then we want to set it. Otherwise, we also want to push it down so that when we do see that sub-segment, if we query it for whatever reason, we can do it this way. And then now, yeah. And yeah. No times 2 + 1 for the left. Oh, mid. Did I do mid? Technically this, but we can also bound it, right? A little bit tighter. But I think that's fine, whatever. Okay. Oops. Typo though. And I think this is done. That's the basic idea anyway. I'm doing it while passing out. I don't know if you could tell, but my eyes are so... I need a nap. Too much Indian food. Delicious, but man, do I need to sleep afterwards. Okay, so then now we just have to find... we have a thing for find 0, right? So self, I guess that's it. Right? Well, I mean, you have to kick it off. So, okay, fine. I guess I wrote it this way already anyway. Zeros. Can type. Something like that, right? And then now, something's a little bit off because we always increment the min and the max. Oh, no, that makes sense. This is for this segment, but the sub segment. Do I have to push it back up? I think I forgot to push it back up. Huh. Okay, so then how did I pull it back up? Oh, I forgot to pull it back up. Okay, so now you did the children. So then this is equal to f min of okay, then now we're good. We'll do it for max, of course. And that's it, right? I don't have to do a push pull. I don't have to change it to the push away or whatever. Okay, so then now we have no left, right. Well, technically, no. Let's just be consistent because I get confused all the time, right? So then now we look at okay. How does a 0 always exist? I guess, I mean, it definitely does not. So then in that case, we want if self.min of node is greater than 0 or self.max of v of node is less than 0, and we just return -1, and that would be means that we don't find anything. Otherwise, then we, and this is, you know, walking the segment tree. So then now that means that this segment does contain a 0. So we see if it's on the left, because on the left is the earlier side, right? So, okay, so mid is right? And then now we go to the left. If, I don't know why I voted this way, actually. No, that's fine. I mean, we didn't need to declare that over there. Okay, so if the min element, maybe I could just write it like this actually. Python magic. If this is on the left, then we return find 0 or self.find 0. Node L mid, something like that. Right? Yeah, because it's on the left. Else we find it on the right. And this can only be true on the root node, because otherwise it just doesn't make sense that you can have a 0 but not on oops. Okay, so that's basically the setup for the segment tree. Right. And then now what I'm doing, and I forgot already. Okay, that's that was a lot, because trying to like you know, segment tree things. Okay, so let's say we have this, right? So here, so let's just say for x in nums, let's also have the segment tree of, is it elements or no, it's just elements. Yeah, nothing too fancy. And then now for each element, I hope this is right, by the way. I feel confident, but maybe I miss an edge case or something, or some understanding, which happens a lot. So if that happens, my apologies. But yeah, so if x, let's just say delta is equal to 1, if x mod 2 is equal to 0, then delta is equal to -1, and we want to modify all the prefix, right? Because here, initially we have 0, I have to add a I guess this is a little bit awkward, because we do have zeros, so this will always give you an element. So this will never happen, but that's fine, because if the first 0 is after this element, then we could check for that instead. I think we want to modify the prefix because so this is 3. Normally I might write +1, but that means equivalently -1 0, right? So we want to modify the prefix, so we have the index. So we want to say, what do I call it again? st dot range add. We want to go from 0 to index -1, except for the index. Okay, so we actually want to do, let's just say n +1, so that the index is actually, the index in the segment trees are 1 indexed because of the extra 0 due to the empty set. Okay, so that means that here, then now we want to, what is my API again? Oh yeah, okay. The 0 is for left index, this is the right index, and we want to add that to delta. And I know that I did it technically opposite of what I did, but it doesn't really matter because it's whatchamacallit, it's symmetric, right? Okay, so oh man, this is terrible. I keep on doing this sometimes. Index. Let's just say f index for first index. If first index is less than index, then now we can check for best is equal to max best index minus first index +1, something like that, and we are Gucci, hopefully, because I really want to take a nap. No, wait, yeah, I mean, I know I missed this in a lot of places, so I might have to do it in a few places. Wait, maybe that's the only place. Well, there's another kicker. Guess not. No, there's a find 0. There you go. That's what I was thinking. But A were given. Range add. 8 were given. Oh, why did I do this? Wasn't paying attention, I think. Python confuses me. Alright, this array element of bounds. Did I mess up the indexing? Oh, maybe I push. No, I mean, did I do something weird? Maybe this is n +1. That would be funny. No, we filled this with n +1, so that didn't even make sense. But why? No, I mean, this should only go up to. What am I doing? Okay. Did I mess something up? Let's just print it real quick. The funny part is that this is not the. Yeah, this is not the part where it should be, right? Yeah, okay, so okay, goes from 0. I mean, 1 1. Do I not have? Oh, I mean, I missed the notice one thing. How did I miss that? I confuse it. Wait, 04. But the thing is that if it's one element, it should terminate. That means something is wrong with my thing, with my left and right. That's why, I mean, I could fix it easily with an if statement, but I don't know that that's the best way. Left, right is 0 0. I mean, the 0 1, it's wrong. Because this is 1 1, right? Well, 0 1 goes to 0 0, it terminates, and then it's Gucci. And then it goes to the right side, it goes to 1 1. How did I miss a... Maybe that's it, right? But... No, it doesn't make sense. Why are we going... Oh, did I miss an if statement? No, it's just this one's wrong. Why is it wrong? So the right it's 0 is less than no left. This should be returning, right? Oh, no. Oh, node left is 1 and 1 is bigger than right? Why? No, right. Oh, whoops. Oh, Larry. Where am I getting it wrong? F index. Oh, whoops. How did I miss this? What a new mistake. Node OR. Okay, I mean, that's fine. I don't know why I keep writing that though. But let's see. Index out bounds. That means that there should be because there's always a 0. Oh, and this is the last element, maybe? Okay. Just... that doesn't make sense, though. When would that happen? This is checking the left. But, again, we have to do it. Okay, fine. Did I mistype some stuff? Also possible. This isn't even print at all. Oh. Also, we don't need the push thing anymore. Oh, okay, fine. Just want it. Okay, so it is trying to find zeros. What am I printing here? Okay, so the node from 0, this is the range it tries to find. 1, 0, 1, 1, 1. Oh, I just don't have a... I mean, this is the termination statement. But, man, I am bad. Just if node L is equal to node R, then we have one element. And then we just return this index, right? Yeah, I mean, that's fine. Yeah. I was trying to think whether, like, because this is not the same as this stuff and it confuses me. But okay. All right. Am I off by 1? I hope I'm just off by 1, maybe. Oh, no, that's not right. This is in the wrong direction of off by 1. I mean, okay. Whew. At least our code runs now, so we can actually just focus on debugging. I mean, we probably should just do like index, first index. We should be able to debug this pretty, it should be pretty intuitive. So the index is 0, first index is 1, so no good. 5 2 should have a hit. they're the same. First should be okay. So it will be we run it real quick. We have 0, add the 2, so then we have changed the prefix to and then we have a 5, so add the prefix to 1. So in theory, it should be like this, and then the first element should be 0, right? Also, the F index is always 1. Is kind of, I don't know, maybe just wrong. Because basically, I would expect this to show for 1 should be equal to 0. 2 it should be 1. It's actually right. 3 would be also 0. What am I doing wrong? That's the annoying thing, is that now, what are you gonna do? How are you gonna debug it? I mean, the correct answer is use a debugger, but because I don't really have one on screen, we can just let's see, right? Okay, so it finds the first 0. That's actually for each query. We want to actually, maybe this is fine as a separator. Right. So it goes 0, 8. What I actually want, I mean, that's fine, is actually also self.min_re of node, self.max_re of node. Yeah, okay. So this is, yeah, I mean, that seems right. So yeah, because yeah, I mean, 1 would be the first one to have it. Okay. This is no longer right, because we do, wait, did I not increment? No, we are increment. We add, so then the second number adds it back, and it shows up on the min and the max, right? Min 0, 2 is right. 0, 1 is right, but 1, 1 is 0, 0 is a little weird. That means that 0, 0 is 1, 1. It doesn't make sense, actually. I don't think that makes sense. So that means the range add. I mean, the range add looks okay, kind of. But it seems like it's always stuck here in the find. Do I not push correctly? Oops. I think the idea is right, but not understanding why this is wrong, or like why. I mean, I understand why it's wrong because the code is wrong, but I don't understand why the implementation is wrong. Because we incremented. I have some typo somewhere, which is always possible. I mean, the thing is that no, this node is wrong. Oh, I'm dumb. Well, no, I mean, I am dumb, but I mean, I am dumb, but it still should be correct for the first one. I'm dumb in that I still haven't, I forgot to do the thing about this thing, which is you only take a prefix of it and stuff like that. So We have to do some maths. But we forgot to do it. I mean, that part's fine, but the first one, it should still at least be correct for the first one, because the first one doesn't have any duplicate numbers. But I did forget about it for some reason. I mean, it's an easy fix, so I'm not that worried about it. We built everything with that in mind. It's just that I don't know how I lost my mind on that one. But okay. But I am still trying to debug the first one first, and then we'll see what happens afterwards. This is already an hour and 10 minutes in. My apologies. It's definitely a tricky one. And maybe I should have said that in the beginning. This is not a good interview problem, so don't worry about it too much. Also, this is just wrong. Do I not update correctly? That is definitely wrong. Because if 0 to 2 is -1, 0, then there's no way there's a 1 here. So there's something really wrong about this. Let's see. I mean, this was wrong, so it can wave. They don't overlap, so you return, right? Yeah, that's right. This seems right. All right, let's see. Should I push? I mean, that's just dumb anyway. I meant this. Let's see what. But something is not updating correctly. That's for sure. Let's go to update pushes a wee bit. Good. Update 0 to 1 is -1. 0 to 8. That's fine, right? Notice on this one, we don't update the 0 to 1. Well, it's just delayed, right? I see. I forgot to, I think on the find 0, I have to update the push. That's why. I see. Okay. Do I have a push ring, right? How do I implement this? Okay. Yeah, okay. So then before we do this, we have to push. Okay. I mean, it's not done yet because we didn't do the unique thing, but that was dumb. And we could probably even test out like a bigger thing that is not, you know, test 4 should be correct. Oh, I was hoping this would be correct. I mean, it's giving 10, which is clearly wrong because we only have 9 numbers. So we maybe have to figure that out, but which is actually not great. Oh, index, F index, index, F index. I mean, F index clearly should not, oh, I'm returning -1 here. And then, so actually what I should return is infinity. I thought that this won't happen, but maybe with the push node it happens. So let's just return infinity. Okay, so then that, okay, that was just a minor thing. Okay. But now we just have to add in the non-uniqueness, and then hopefully we're done. Okay, so let's go over the non-uniqueness because I've already forgotten it, right? Let's take this case, for example, and just for testing, we'll just double it. Because maybe that's more useful. Okay, let's get rid of this for now. Okay, so here we want to say we have a prefix 0, and then now we add the 3, that's a +1, so we just subtract 1 from the prefix, okay, and then now we have a 2, so we set the 2, and this is going to be +1, and this is going to be 0, right, so we add 1 to the prefix, right, and then now the second 2, okay, second 2, what do we do? The second 2, what do we do? That almost sounds like a nursery thing. But okay. Well, we want to set this to 0. But we only want to update up to the last 2. Is that true? Man, everything seems to wipe. We only want to update to the last 2. No, last 2. Is it true? I don't know. I'm not good at all these things. But yeah, I think that's the case. Right. Well, yeah, you don't even update to it because then now you you do update to it. So then now this is actually this is a -1. I always forget which direction. No, because this you wouldn't hold this to reach this one, right? Wait. So then what is it? But what you want is this because the 2 doesn't change anything. And maybe that's it. You just don't update anything because the 2 is here. But we want something, I guess the next 2 will clarify for us, right? Because we have 5, that means -1 to all the prefix. Let me just write that out because I keep on mixing them. Right? Okay, so you have 5, so then this is 0, you have -1 to all the prefix. There's going to be -1, -1, 0, -1, right? Something like that. Oops. And then now you have 4, which is going to be +1 to all the prefix. I'll just do it here. 0 +1, 0, 0, +1, and then 0, right? Okay, and then the 3 is going to be -1 to all the prefix. So then now you have -1, 0, -1, -1, 0, -1, and then 0, right? Okay, so you have this as a thing. Oh, no, I can't. I forgot that we already have a 3. So then now what do we update? We update from here all the way up to the last 3, right? We just don't update the prefix 0 because that 3 has no effect on it. So then now we say this is 0 because that doesn't have impact anymore. -1, -1. Is this right? Yeah. Okay, so I think I get the idea then, right? Because then now these are impact, and then if you look at it backwards, then this no, this 3 keeps the, no, that doesn't make sense. So you wouldn't jump, right? No, it makes sense. Okay, because then now this is 0, but then it means that there's no change to this. So not, but I'm looking at the transition from the -1 to 0, but that's actually the 2's impact and not the 3's impact. And then now when you have the 2, then now you only go up to the first 2, right? Okay, so then that part is easy once we kind of know, right? Because then now we have, say, let's have a last index is equal to lookup map, right? And then this is just if x is in last index, or if x is, yeah, let's not do double negative yet. Then otherwise it goes from last index of x to index and then delta, right? Something like that. Oof, still wrong, huh? Am I off by 1? Well, no, I just didn't update last index. Larry. Okay, a little bit closer, but we want to, I mean, you know, this is just going to be not great, right? I have to up. No, do I? I was going to say I have to do this before this, but I'm not quite sure that's true. Because it shouldn't matter. This doesn't change the last defined 0 part. But we might have to debug this. It's giving me 2, though it should be 3. Is last index inclusive? Maybe I need to do -1 or something. Oh, yeah. I mean, actually, not +1, because I forgot that this is 1 based, right? So we have to. This is the 1 based version. Okay. Okay, still wrong, but I think that's more accurate though. Because as we said, because everything on the range, the first index is the empty 0, so this should be more accurate. But why is it coming 2? All right. Thought I was so close. Okay, so it only comes here to here, right? So that means that the 2 is not matching this, which, you know, I mean, it's not great. That seems right. Everything else seems right here, so I have to go back into the thing, which is what I didn't want to do it. Okay. It goes from 0 to 8. Why is this 8? Oh, because it's +5. Fine. Okay, so this is 0. I think this is only here, right? So we might have to do something like. Okay, 0 to 8, 1, 1, 0 to 8. Okay, what am I supposed to write again? What am I expecting? So you have 1, 2, 3, 2, right? So you have an empty 0, empty set 0. You see the 1 is -1 to prefix, so it's -1, 0, right? And then now the 2. The 2 is +1 prefix, so 0 +1, 0. So this correctly finds it, I think. Yeah, because this number is off by 1, but that's fine, right? Or 1 index rather. Okay, and then the 3, you have 0, -1 to the prefix, so this should be -1, 0, -1. So this should at least have an answer on this part, for sure, right? But it's finding negative. I might have done the addition on the odd number instead, but that's fine. Why? Why do you update? Or what do you update? From 0 to 2? I mean, that should be right. We didn't see any 3s. So here, the 0, 0. We change all the numbers. We don't pull. So push is fine for updating this number, but then we have to pull before we. Is that good enough? That doesn't make sense though, because if it. Why would it be 1, 1 still? So we update this. Because this should not be 0, 0 in any case. There should be a 0, 1 or something. Right? So something's. I'm missing like a push or a pull from somewhere. The problem is that you can't go deep, right? Maybe that's fine. Yeah, maybe I should have had a pull function. No, this. No. On push, we already updated children. So the children already has the numbers. What am I missing? Huh. Okay, so this is fine, but then when you push, when you update, no, I mean, this push doesn't do anything, does it? This push just does this. No, I mean, it does stuff because this part is recursive, but mess something up. Oh. This should be updated because of the push. Oh no, because this doesn't. No, yeah, this should be updated. Unless there's like some recursive thing that I'm missing. Like, would it work if I did something like this instead? If. Whatever, right? Something like this. It's still wrong, so I don't know. Oh, why? My lack of segment tree things are coming back on me. But yeah, 08 is still range 00. We update. This update is not enough. No. I mean, I guess it's fine, but it updates 01. Where's my update? I thought I was done. And I probably am mostly, but okay. So updates 01 to decrement. So it updates this, and this. But this does not update 01. No, it uses this, right? That means 02 is wrong, right? Because left and right should have to. Do I have typo or anything? I don't get it. Because if you update 01, then only 01, right? So 22 would be a different thing, and 22 would be 0, but 01 would 22 would be. Maybe it starts from here. I'm too tired for this. Okay. You're updating 0, 0. I mean, this is wrong too, honestly. It should not be 1, 1 for this because it just should be 0, 1, right? Or 1, 0, or no, 0, 1 or negative 1, 0. This is not right. So there's something wrong with the thing. This is why I usually use template during the contests. It's been a while. I should be able to do this. It's not, you know, the left, right, right. Node, left, right. I mean, I don't get it. I want to update 0, 0. So it goes to the left. Mid is going to be 0. Right. So then this should be updated with 1. But then the other number should be 0. This should be 1, 1, right? 1, 1. One should remain 0. Do I push? No. Oh. Is this first? Did I mess that up? I mean, it's still the same, so I don't know. And also, I don't know. What? I'm probably having like a really dumb typo somewhere that I'm like missing. Because I am not happy right now. But, yeah, okay, fine. This is where you need a debugger, really, to be honest. Because right now, this is just annoying. Right? Okay, so we have 0. Wait, no. Yeah. 0, 1. 2, right? But it doesn't go into 1, 1, which is fine. Then why is this wrong? Should be have a 16. Okay, so that's right. And it doesn't update, presumably. Am I doing something weird here? I mean, I declare everything as 0, so everything should be 0 to begin with. So 1, 1 should be 0. So why? Why are you not giving me a 0? Why are you giving me a 1, 1? Okay, fine. Okay, let's see if that is projected first. Okay, update left axis 1, 1. That's right. Let's see what's on the right side of chaos. When we're looking at update 0, 0, which is also right. So the right side is 0, 0, which is what we expect. The left side is 1, 1, which is also what we expect. The min, min should be 0 then, right? Losing my mind? My F-min is wrong, isn't it? You mother. Oh my. I was feeling like I had this feeling that I've done this before. And I have done this before where I got the F-min wrong, and that's why I was like, that's the worst typo. That's what happens when, why did I look at, I know that I wrote this in a weird way because I was writing it really fast, because I remember I wrote something like this, if you recall, and I was like, oh, yeah, just put it in, but then got confused and then I didn't look at it again. Okay, so that was very dumb, in fact. And we were able to do, I mean, if you take out the last 10-15 minutes of me just being dumb, that was not that bad, maybe. All right, let's hope we don't time out or anything. This should be analog n, but with segment tree, the constant's always a little bit high, so man, that is stressful. Well, not stressful, just tiring, just a grind, just an endurance, just a marathon. I'm very tired. I'm curious what I did last time. Yeah, I mean, got it on the first go and faster today too. What did I do last time? Well, I did the same thing really. I even did the walk. Looks like I also did a lot of debugging on that too. Why is it slower though? Okay. I mean, we did the same idea, I suppose. Probably watch that video. I probably spend more time describing it, honestly. On this video, look, it's an hour and 40 minutes. I'm already tired. Look for my old video, and then hopefully that's a little bit better. Oh, why did I keep track of current? I don't know why. Oh, because instead of tracking I did it the other way of, I mean, I had two, you may recall that I had two ways of doing it. One is finding the first zero. The second is just searching for the number. I guess I keep track of the currents of that. If it's equal to zero, then we just go. But yeah, this is gonna be analog n. There's a lot of segment tree. Like I said, this is a ridiculous interview problem. Though I feel like I got most of it in like an hour-ish, but I made very silly typos. A really inexplicable one even. But so I was like, I don't, you look at the debugging log and you just, doesn't make sense. And I don't know, at least I don't usually question my min functions, but today, min is my mistake. But yeah, but this is the code for the idea. I don't even know what to say anymore. I mean, it's just the code, right? Like, you saw me grind it out. I did everything from scratch, which is why there are so many mistakes. But you get a little bit better. Hopefully next time I'll be slightly faster, and then eventually be a little bit fast. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.